think the tape is rolling, so we can start. So it's my pleasure to announce Jorge Galvis.
Yes.
I mean, whoever analyzed that correctly, who is passionate about working with web development and currently working at a huge company. And we will introduce you to a funny word of function as a service, also called FaaS. I'm giving you the mic.
Thank you. Nie mówię Deutsch po polsku, that's why I'm going to talk English. So, thank you for coming. I'm very honored and kind of getting the chance of sharing a little bit what I have been doing regarding FaaS. I'm Jorge, Giorgio, and a technical lead at Huge. And this is my Twitter. I usually retweet. I don't tweet that much, but it's kind of my library for learning new stuff. I hope you know where Colombia is. It's in South America. I'm working currently at Huge. In Medellin office, we got 2 offices in Colombia. Huge is a digital agency that started creating only designs and UX experience, but now it got an engineering department as well. So we create things that looks like nice, but also performs like nice as well. And we're going to talk today about function as a service with Python. And in this case, we're going to use Google Cloud Platform for deploying some small functions. So we're going to be defining what serverless is, what FaaS is, if we should go with serverless or not. Very opinionated talk, by the way. If you want to use Python, how can you do that? Small demo and conclusions. So serverless. I guess you have heard this word a lot, but basically it's a new execution model in which the cloud provider is taking care about the provisioning and the maintenance of the underlying servers in which you are going to run your software. So if you read this chart from the left to the right, the more right you are, the more serverless you are as well. So we started with real servers, like a bare metal servers. Did you have the chance of kind of installing an operating system or configuring a rack, a server? I got the chance as well, and it was painful. Then we got services like DigitalOcean or Linux, in which you can create virtual machines. Then we moved to the right, and services like, or companies like Microsoft, Google, AWS created a lot or a set of services that made it easier to deploy infrastructure for applications. Then we got platform as a service, which is kind of a mechanism in which you tell to the provider how your application would run, and you don't take care about the service as well. And we move a little bit further and reduce the unit of work to a function, not a complete application, but just a function. We're going to talk about this new model. So I like this definition about serverless. I took this from fullstackpython.com. They say like serverless is a new deployment architecture where you as a developer don't provision the server, but instead you deploy a piece of software that will react to an event. And this is very nice. So in more colloquial words, you deploy a function, and then you attach that function to an event, and then when that event happens, your function will be executed. And that's it. This is how it works. It's not that easy in real applications, but this is the core concept. So This brings kind of some benefits. First one, and the one I like the most, is that we don't need to take care about the provision, or about the maintenance, or about to update the operating system. So this is a thing that the provider does for you. So with this new model, the same piece of code that you use for one request will be exactly the same one as if you get 1 million requests, because it scales out of the box. The provider is very good at creating new versions of your functions, so the traffic that you will receive will be attended. So you don't need to take care about balancers or creating new machines according to the request, the amount of requests, etc. And this is how you can convince your boss or the people who have money at the company, and is that we're going to pay only for the execution time of the function. If you have a virtual machine, for instance, or a database server, you're going to be charged always, because it's always running. But in this case, since the function is regularly sleeping, when a request comes to your server, it will create a new container, it will attend that request, and it will go to sleep. And you're gonna get the bill only for the time that the function was running. So, if we want to deploy a function, we need to kind of switch a little bit the mindset for the development. As I say, the unit or the core of these are functions, so we need to kind of write and write. And this means like the functions need to be speeded, simpler, and singular. And speeded because remember you're gonna get charged for the time execution, and using the units philosophy here, functions should do like one thing, should do it faster, should do it properly. You need to think or consider that it's kind of really a bad idea to try to keep a state between calls. So the instance of the function that is attending my request is not the same one, or might not be the same one that is attending yours. So you cannot have like a shared state between calls. Okay? But you can use services in order to save what you were calculating. And one call could be taken by a Linux server, and the next one by a Windows server. So your implementation needs to know nothing about the operating system that is behind the scenes. So your code needs to be hardware agnostic. And as a regular application, don't take for granted that there will be retrying mechanisms. Try to implement them yourself if possible, or if not, check the cloud provider documentation for kind of getting know how these retries will work. So, should we go serverless or not? In my opinion, if you have an application with WebSockets, you shouldn't go serverless, or not serverless, but with FaaS. Because the whole idea of WebSockets is to keep a connection, right, with the client. But if the function is going to sleep, and then it will wake up, it's not the same instance of the function, so it would be really hard to have a communication there. Plus, you will you will have to pay more if you want to keep your function running all the time.
Google platform supports WebSockets?
No.
AWS does.
Yes, with Aptin and
No.
API gateway or if you want to serve static content, maybe you should use a CDN. And I think that the applications that fit the most are like APIs or backends that works as an API as well, especially if your activity is kind of low and you get some fixed time to time, and then it will go to the regular traffic. And this is because of money. You know, if let's say that you have a base number for requests and everything is like okay, and you get a peak, you don't need to get up late night and see what is going on, because the provider will instantiate the new instances for you, and then you will get charged just for those peaks. And I had seen like we are using more and more functions like a cronjobs. We need to run a function every, I don't know, 10 minutes, 5 minutes for doing an activity. I have worked on this option as a backend for an IoT project, and it's like in this case it was an IoT core which was connected to an edge device, and then we were sending data to WhatsApp, and then the function was reacting to that. Basically, we were taking the data from that message, and we were sending this to the web. And I had seen it as well working as a data pipelines. People is using small functions, and they are connecting them and building a pipeline for moving data, let's say from a Postgres database to a BigQuery as well. So those are the examples I was talking about as a backend, as a IoT backend, or if you want to move data from your application to a data warehouse. Right. Or you can also do cool stuff, like if there is a commit or a new pull request on your repository and it supports webhooks, you can connect a function that reacts to that and send a message to the Slack. But nothing is for free. So, there are some disadvantages as well. First one is vendor locking. You need to kind of spend some time in order to know which provider is going to fit your needs the most, because they offer different integration with other services. And if it happens that you deploy your function and you, let's say you started with AWS and it started cool, and then you started to use DynamoDB and then this API, that API, and for some reason you need to move to another cloud provider, well, most likely the other provider won't have DynamoDB or won't have the same APIs you were using on AWS. So that's vendor locking. That's what vendor locking means. Sometimes it's really hard to switch. It's not impossible, but it's hard. And cool stores, if there is not instances of your function running because there is not traffic, the first instant request that will come will suffer something called cold stars, and it's the time that the provider is spending in order to get a new instance of your function and put it in their app and running. So there are many articles or documents that kind of mention this topic. I don't really think that this is a disadvantage. It's just the nature of the new execution model. We need to live with this, to cope with this. Cold starts are required, are needed, because otherwise it wouldn't be serverless, right? There are some mechanisms in which you can keep your function like a warm, like a be more ready for upcoming requests. But my suggestion is better think about if serverless is what you need, instead of making serverless to support your regular traffic. Vendor restrictions. Many providers have different time execution limits, memory allocation. So do your math before to deploy anything. And observability is harder. And this means like well, if you have only one function, you can go to the logs. You can see what is going on in case of failure. But if you deploy something like this, because your application is all based on functions, and one function can call another one, and this another one can call a service that can write to a message that can call another function. It's really hard to know where something can fail. And it's really get this from the logs or from the native tools that providers usually offer. So you might need to use an external service for kind of getting visibility of what is going on behind your system. Right. Let's say that we have done the math. We are pretty sure that what we need is this, and you want to know how to do it with Python. So first thing, let's pick up a provider. There are more of these three. AWS offers Lambda, Azure offers Function, as well as Google Cloud Platform. So we're going to use Google Cloud Platforms for this talk. And if you don't want their solutions, you can even deploy your own or kind of an open source alternative on your premise. And so you can find OpenFaaS, OpenWhisk, and Vision.io. There are others as well that you might want to try. So if we want to deploy to any of the providers you have selected, we can do it using the tools that they offer, or we can use a framework or a specialized framework. Serverless framework is this NPM tool that allows us to deploy functions in kind of any runtime for AWS, as well as Chalice. And there was a talk yesterday about Zappa. Today we're going to use kind of the UI interface that the provider is offering. There are other frameworks like Cloudea.js for, I guess it's called Cloudea, for using Node. Architect is another framework. I have some reference at the end of the talk that you can check. So, let's do the demo. Great. Let's check if we have internet as the first thing. I have already created an account on GCP, and I have already authenticated against from the command line. So what we want to build is small function. This is the hello world on GCP using Python that will just kind of render a message on the browser. So the first thing it's asking for is the name of the function. Let's call it, of course, hello world 2. This is very important that you're going to get charged for the execution time, but also for the resources allocated to your function. So if you know how much run is going to, actually you should know before to deploy this to have some idea about how much run you're gonna need. For rendering a message, I'm pretty sure that this value is enough. And this is what I was saying, like you can attach this function to an event. In this case, I want to make this to react to an HTTP call. So I'm selecting HTTP, and you can upload or take the function for a Google Cloud repository. I'm going to select online editor, and I'm going to check Python 3 as the runtime. So what will happen is that the provider, in this case Google, will create a container based on Ubuntu. And behind the scene, they also have Flask and some packages already installed. There is a kind of advanced configuration, and something that I want to remark here is the regions. Think about your users before to deploy the functions, because the closer your function is to your user, the less you will have to pay because latency. Okay? And let's create it. So I have already created a function that is similar to that one. Let's wait. So in here you can see like the resources that I am attaching to this function, who has deployed this, but the thing we want to check is the trigger, as I set this function to react to an HTTP call as well. We should see the result from the browser. So you can see I have created a small endpoint using only the web UI from the provider. Good. And the second one got deployed. And if we check the code, you might see this, like it is very familiar. Have you used Flask?
Can you zoom in?
Yes. Better? Yes. It looks like a Flask, right? Like a Flask endpoint. So if you have got the experience with Flask, you're going to enjoy this. If not, you're going to enjoy it as well. But this is not kind of the things we do day by day. We usually create more complicated things. So let me deploy a function from the command line or using the gcloud CLI tool. If you want to deploy a function from your machine, what you have to do is create a folder that contains, basically we need one file, a main.py module, in which you need to define your code. Here we have kind of a set of functions that will call the Google API for goods. And then we're gonna kind of go through the answer that we will get from that API, and then we're gonna render this to the browser. You might be wondering, okay, you have three functions, which one is going to be executed? So at the time of defining the function, we didn't see this on the UI, but you can choose the entry point. So it doesn't mean like that you need to deploy only one function, but to tell to the provider which function is the main one, right? And something that is different a little bit from AWS is that you can also define a requirements.txt file for defining your dependencies, and Google will install the dependencies for you. If you remember, on AWS, you need to kind of bundle the dependencies on your own. Or get help from a framework for it. So let's deploy this. So we use the eCloud tool. That's kind of our interface for talking to GCP. We want to deploy this as a get ebooks version 2. The entry point is the function get ebooks by author, the region, the runtime, and how this function is going to be called. In this case, it's going to be a HTTP call. So let's hit it and let's wait. I have already deployed a similar function, and what you're gonna see, well, now you can see that it's getting deployed, but this is the one I have already set in there. And let's check the code and the trigger. So again, these are the resources attached to it. The trigger is this URL, and the source is just what I had on the main.py module, right? And the entry point is here. So now that the function is there, it's here. We can see like there are some books in there. I can use some filters as well. So again, we have just created a new endpoint that consumes another service, and we are returning it to the browser without taking care of service. Right, 5 minutes. So, let's wrap it up. FaaS is another architectural approach or execution model for apps. No, not all apps need to fit in this approach. And this is kind of always what I tell to people that, look, if your application is working correctly, perfectly, as it is, you don't need to move. Why do you want to move? But if you need to save money, or if you see that you are not using your resources like at the best, then switch. If you are not saving money with function as a service, probably you are doing it wrong. So make your math, and remember that it auto-scales. So the same code you deploy for one function will work for 1 million. Your code will scale as much as the code inside the function will scale. If you have code that talks to a database and the query is like slow or to another service, well, it won't scale, right? So take that in consideration. Sometimes people blame on AWS, on GCP, but if you see the content of the code, they are not magicians. Explore your functions, run this in local, make it performant, and then you will see that it will scale. Here are some references, and I have written an article a few months ago about this topic. Thank you very much. I had more energy this morning, but in the afternoon the jet lag is kind of killing me, so I'm kind of down.
Okay, there are no questions on Slido. It's all that the Slido still was available, there was none, so if you have any questions, please raise your hand. I will go to you.
Error. Redirect.
You were talking about the cold start of functions. How much time does it usually take for a function to actually start, and usually, and also how much time does a function take to become called again, so that we know hopefully we have to, I don't know, reload it.
Yes, this change from provider to provider. The amount of time that a function takes to kind of get up on GCP is different from AWS. I don't have the number even from GCP, and I don't think they can give an exact number. But in my experience, in the ones I have deployed, after 28 minutes, you can see like a request after that period of time are suffering a little bit of delay. But once the instances are there, it's just a matter of milliseconds again. And the call start time could be what I had seen, 3 seconds, 5 seconds, 6 seconds, 10 seconds. It's not like a 5 minutes.
Azure, it can be 5 minutes.
Yes. Let me give you this.
He has gifts for the questions.
How are you?
I've got a question because you mentioned that we pass requirements .NET file to install packages, but what when we don't have packages available publicly, some storage or etc. Can we install it in add it somehow to deployment package?
Yes.
Like on AWS?
Yes, on GCP supports 2 kind of flavors. One is using the requirements file, and the other one is using the bundle, which means a folder with an image module with your dependencies.
Okay, and what would be the limit of the size of the package?
I don't have like an answer for that, and I guess we need to check the documentation and see what's the size, but I don't know. Also, something to mention here, the provider also installs some dependencies for you. I mean, you don't need to install class, you don't need to install requests, they are
AWS is 50 megas or was 50 megas.
50 or
Anyone else?
My question is also related because that's the problem on the first function scale code or on each code. I mean, the functions are running asynchrony. They scale. So one function can be running at the same time by 100 requests. So the problem will go only for the first code, for the first instance of Lambda, or for every instance?
It all depends on the amount of instances that your function has like currently, because let's say that you have like a 10, 15 instances running, right? And they are enough for the current traffic you are receiving. But if there is no traffic suddenly, all of them will go to sleep. So the next one will suffer that. But let's say that the traffic just got cut like a little bit. Not the full traffic, but just a percentage of this. The call start won't or shouldn't be that hard, because still there are some instances in there. But I guess this is something that the provider decides for that. There is no way we can control.
Thank you, Jorge. That's all of the time we have. Next speaker is Super. Please give us a hand to Jorge.